Hi. To ensure the data integrity during the network transmission, we need some error detection technique. In some cases, we need some error correction technique. One such error detection technique is the cyclic redundancy check method. So, we'll discuss about the cyclic redundancy check method here. Looking into the screen, you can see computer A and computer B. Computer A is the sender and computer B is the receiver. Now, computer A, which needs to transmit some data to receiver, computer B. Imagine we're going to send a message hello, and here just for an assumption, the hello is represented as a bits 1001, and so this 1001 is actually called as the data word. This is called as what? Data word, which needs to be transmitted. But the case is we cannot send this data word alone into the physical transmission medium, because in case if any error occurs, in case if any noise or interference occurs, this actual data may get altered, and what receiver is receiving is something different from what we have actually transmitted. So in order to avoid this situation, we are supposed to add some redundant bits along with this original data word. So this original data word is of 4 bits. We can say this is K. Okay, so here K is actually 4 bits, and we are supposed to do some encoding process. So in the sender, in CRC method, in the sender side, we call this technique as CRC encoder or CRC generator, and on the receiver side, it is called as CRC decoder. Technique which needs to be performed in order to receive the actual, in order to actually recover the original data without any redundant bits. Redundant bits are nothing but some additional information that is added along with the data word, so that we can detect the errors, which happen during the transmission at the receiver side. So receiver actually removes these redundant bits, and the original data word will be given to the higher layers in order to process and receive the original message which was transmitted. We'll see into the process in deep. So as I said, here the data word, the sender side, the data word which is of k bits, that is actually 4 bits. The code word which needs to be generated and need to be transmitted from the sender to the receiver is of n bits. So n here is equal to 7. So look into the sender here. The code, actually we don't transmit the data word, we need to add some redundant information, and so it is actually called as code words. Okay, so K is the actual data word, R is the redundant bits that need to be added, and together all this is actually called as code word. The code word's length is of n bits. So imagine a situation, if we have n is equal to 7, it means then we know already K is equal to 4 bits, n is equal to 7 bits. So in this case, the redundant bits R is equal to 3 bits. So we need to add some 3 bits as the redundancy. These 3 bits is the additional information that we need to be transmitted along with the original 4 bit of data. Okay, so the size of the data word is now augmented by these redundant bits to the right hand side of the word. So while performing the CRC encoding process, that is when you want to generate the redundant bits that need to be added with this data word, during the generation process, along with these 4 bits, you are supposed to add 3 bits of zeros. We are supposed to augment 3 zeros along with this 4 bits. 3 zeros along with this 4 bits. And then we know the data word which is augmented with the redundant bits is going to be the dividend, and we are supposed to look into the divisor. So here we have some predefined and agreed upon divisor, and this divisor length, we are supposed to think about the divisor size, right? So the divisor size will be like this. So n minus k plus 1. We already know n is 7 and k is 4 plus 1. That means we're going to have 4 bits of divisor that is to be used along with this modulo 2 division that needs to be performed at the CRC encoder side. We'll look into the modulo 2 division that needs to be performed in the CRC encoder side first. Then we'll see how CRC decoding process is happening. So in CRC encoder process, The data word is actually, we can take the data word as 10001, and a divisor which is of size of 4 bits. See, as I told you, the divisor is a predefined or which is agreed upon. So here we can choose a divisor of one like 1001. No. Okay, remember, we just going to perform a CRC encoding process at the sender side, and we know the data word is of 4 bits in size, which is 1001, and we have a divisor which is predefined and agreed upon, which is in the size of 4 bits, that is 1101. So this is actually predefined or agreed upon with this divisor to be used for performing a mod load 2 division. And students, remember, we are supposed to augment 3 bits of zeros along with the data word while performing mod load 2 division. You know, the actual data word size is 4 bits, am I right? So data word, this is actually 1001, and augmenting 3 bits of zeros, so the total bits are actually 7. Okay, so this is what we call as code word. This is what we call it as code word, and we are supposed to use this as the dividend, where the divisor is already there. We have to perform a mod load 2 division during the CRC generation process. That means we're going to perform a mod load 2 division, and the remainder of this mod load 2 division will be a 3-bit CRC code. So this 3-bit CRC code will replace this 3 augmented 0 bits, and it will be transmitted into the network. Okay, so this is how this is what we're going to do now. So let us look in deep how this CRC generation process is happening. Okay, so now we look into the CRC encoding process. Here we have a data word 1001 and the divisor is 1011. Let's see how a mod load 2 division can be performed over here. Look into this. We use this data word 1001, which is augmented with some 3 zeros during CRC encoding process. 3 zeros which needs to be augmented during this CRC encoding process. And why do we actually have to add 3 zeros? Actually, the encoder takes a data word and augments it with n minus k number of zeros. So n is actually equal to 7. N is equal to 7 and k is equal to 4. Alright, n is the total encoded bit. So n minus k, that is equal to 3. So 3 bits of zeros needs to be added along with the data word. And then we have a divisor where the divisor is going to be 1011, which is predefined or agreed upon. Okay, we'll talk about why it is actually predefined and what is happening. So why do we choose this 1011 later? Actually, it is predefined. As of now, think that it is a predefined divisor we're going to be using. And look into this. We have to perform a mod load 2 division operation. So 1 times 1011 is 1011. Yeah. Now it is 0. This one is 0. This one is 1, and this one is again 0. See, you are not supposed to use this. You can remove this bit and look into the very first bit, most significant bit. Okay, now you can see the most significant bit is 0. So in this case, you have to drop down the next bit and you have to multiply this with 0. You have to multiply this with 0. Now 0 into 10. See, only when the case of this most significant bit is 0, you are supposed to multiply it with 0, and so it will look like this. Am I right? 0 into 1011 is this. And now we can see 0, 1, 0, 0. You can again remove this most significant bit. You don't need to consider this. And look at the next most significant bit now. It is 1. So now you can drop down the value. And it will look like this. Again, 1 times 1, 0, 1, 1, and 0, 0, 1, and then 1. Am I right? So this is how it is going to look. Again, the leftmost significant bit, after removing this, if you see into this most significant bit, it is again 0. So now you drop down the value, okay, and multiply it with 0. Now it is again 0, 0, 0, and the result will be like this. No more bits to drop down. You can omit this 0 actually, and we have this last 3 bits as 1, 1, 0. Students, remember, you no need to care about this quotient, but the 3 bits that we got as the remainder, this is the most important one. These 3 bits are actually called as the CRC bits. This remainder is actually called as CRC bits. So we already know the data word is 1, 0, 0, 1, and we have augmented some 3 bits of zeros during the modulo 2 division that need to be performed. Now the actual data word which is to be transmitted from the sender side, that is equal to 1, 0, 0, 1. So instead of augmenting these 3 bits of zeros during transmission, you are supposed to augment the CRC bit, that is a remainder of this modulo 2 division that we performed in the CRC encoder process, and we have generated this CRC bits, that is 1, 1, 0. Please keep it in your mind, this 1, 1, 0 is the remainder of this operation. 1, 0, 0, 1 is the actual data that need to be transmitted. So now from sender, we are supposed to transmit this data, this code word, to the receiver. Okay, so from sender, this code word will now be transmitted into the physical transmission medium to the receiver computer B. Receiver computer B. Okay, so this is CRC encoding process. This is CRC encoding process. Okay, so we just see how CRC decoding process is happening at the receiver side. Students, you have to think of a situation. Right now, the received code word that I have in the board is actually 1001110. That is what we have actually transmitted is being received at the receiver side of this scenario. Okay, I mean, there is no error that has occurred. Some cases there may error occur in the during the transmission of this data from the sender. So the code word can actually change during this transmission. Okay, so but here what I have shown you is there is no any error in the data. So we have received the actual data which was transmitted. Okay, but the receiver does not know whether it is the actual data or whether it is a corrupted data, because it needs to make the decision whether it is the actual data or corrupted data once after performing the CRC decoding process. So here the decoder does the same division process which is happened at the encoder at the sender side. Okay, so the remainder of this division at the decoder side is actually called as a syndrome. Okay, so here we have some condition, like if we performing the same modulo 2 division at the receiver side for CRC decoding process. Okay, so this received code word will be used as the dividend, and the divisor will be the same what we have chosen for CRC encoding process. Okay, what we have chosen in the CRC encoding process is 1011 as the divisor, right? So the same we will be using here, and then we do the modulo 2 division process, and the remainder value, that is what we call it as a syndrome. Okay, in case if the syndrome is all zeros, that means the remainder 3 bits is going to be all 0, then there is no error. Okay, then there is no error in the received code word. In case if there is data word, that means if the syndrome, that is the remainder of this division, is not actually the zeros, it has some values, it means then the entire received code word is corrupted. Okay, and the entire code word will get discarded. Okay, so we can first see a scenario of CRC decoder where we have received the actual code word which was transmitted, and we can do a modulo 2 division process, and we can see what is the remainder, and we can make a decision whether it is the actual data transmitted or not. Okay, and then we can have another one scenario where the received code word we may change some bits, and we can do the modulo 2 division operation, and we can look into how is the reminder and how the actual code word is discarded. Okay, let us start with the modulo 2 division operation. And yeah, so the received code word which is going to be used as a dividend is 1001110. Am I right? So this is the received code word that is used, and divisor is 1011. So this is the one divisor that we actually use at the sender side while performing CRC encoding process. This is happening at the receiver side. So we can do the modulo 2 division. So 1 times, so 1011. Alright. So this will be like 0 0 1 0. You already know you need to remove this bit and look into the most significant bit now. If it is 0, you have to drop down the value and then multiply it with 0. So it is 0 0 0 0. Alright. So now again you will have 0 1 0 1. You have to remove this most significant bit and look into this most significant bit. It is 1, so you can drop down the value and perform the multiplication with 1. So 1 0 1 1. Now look up to this scenario. It is 0 0 0 0. Okay, so removing this most significant bit, look into the first bit. Still the first bit is equal to what? The first bit is equal to 0. So you can drop down the value and multiply it with 0. So again 0 0 0. Okay, so it will be like this. The remainder, after omitting the most significant bit, you can see the remainder 3 bits is equal to what? Zeros. So in case this is going to be the remainder, of this CRC decoding process, and keep it in your mind. This is what we call it as a syndrome. So the syndrome while performing CRC decoding process is equal to 0 0 0. If this remainder is 0 0 0, it means the actual received code word is not corrupted by any noise or not corrupted with any errors. So the original data word, after removing the augmented bits, the original data word 1001 can be accepted by this corresponding layer, and it can be processed to the upper layers or towards the lower layers depending on the requirement of the user. So the thing is, here we ensure that there is no any error occurred in the code word during the transmission. Only when syndrome is 0, we can ensure that there is no error. In case if it has some values, it means there is some error. We can have a look into that scenario. Like we can change the bits in the received code word, and then we can make a decision like whether the error has occurred or not. Okay, so I hope that you can understand this. The same operation what we have performed in the CRC encoder side, but in CRC encoder side, along with the data word, you have augmented 3 zeros, whereas in the decoder side, the remainder of the encoding process, that values will be added and will be transmitted. So while receiving, we will receive this, and this is used as a dividend, and the same divisor is used. Same operation will be performed. If a syndrome is 0, it means there is no error. There is no error. Okay, students, now look into the scenario. We're going to perform the same CRC decoding operation, but now the received code word, actual code word that we have received is now been corrupted during the transmission, and the received code word is now changed into 1000110. Okay, due to some noise during the transmission, the received code word is now 1000110. Okay, now what we have to do is we have to perform the same modulo 2 division operation, and we have to check with the syndrome. In case if any value is there in the reminder, that is in the syndrome, then it means that the data received, the data word that we have received is actually corrupted by noise, and so it should be discarded. Let us do the modulo 2 division and we can see what is the result. Okay, so yeah, we can do this. Okay, the received code word is 1000110. Okay, hope you remember that this 110 was the 3 bits augmented with the data word during the transmission. This 110 is actually the reminder of CRC encoding process, which was augmented along with the original data word. But during the reception, what happens in the original data, due to noise, 1001 is now altered as 100. Okay, but the receiver does not know whether the error has occurred or not before performing this CRC decoding process. Okay, so let us do this. So the divisor is same. The divisor is same. That is 1011. Okay, 1 times 1011. So it is 1011. Sorry, this is actually 0. Yeah, 0. And you are supposed to remove this and look into the most significant bit. The most significant bit is now 0. Okay, you have to drop down the next value, next bit. And since the most significant bit is 0, you are supposed to multiply this with 0. And so it will be like this. Okay, so now 0, 1, 1, 1. Okay, so remove this most significant bit and drop down the next value, because at one time there should be only 4 bits. So drop down the next value, it is 1, 1, 1, 1, and multiply it with 1. Since the most significant bit is 1, you can multiply it with 1, and the result will be 0, 1. Okay, and then 0, 0. Okay, so remove this and look into the most significant bit is 1 still, so you can drop down the next value 0. Okay, and multiply it with 1, so it is 1, 0, 1, 1. Now 0, 0, 1, 1. It means removing the most significant bit, you can see the remainder is 0, 1, 1. So the syndrome of the CRC decoding process has some value that is 0, 1, 1. Only when the syndrome has a value of 0, 0, 0, then it means there is no error in the received code word. In case if the syndrome has values like 0, 1, 1 or any other value, then what happens, other than all the 3 bits are 0, if it has some values, it means the data word is, received data word is corrupted. Okay, received data word is corrupted by error, and so the data word is now discarded. So receiver can understand the data word has been corrupted by some error, and so the received code word is now discarded since it has some error.